Today's material, we're going into section 3.2, and this is going to be covering a new number for us. Every number we have dealt with so far has been the real numbers. In Algebra 2, we get into complex numbers, a whole number set of new numbers that contains our real numbers. Here's why this has to be used. Here I have a quadratic equation, and we've been solving quadratics, and just the other day we solved them by factoring. But we also used another method called the square root method. So for example, if I had x squared equals 9, I could square root both sides, and x would be, we had to put plus or minus, and the square root of 9. And the reason square root of 9 is 3 is because 9 can be written as a 3 times 3, and that's what square root is asking. What number is multiplied times itself? In this case, 3 is multiplied by itself to get the 9, therefore the square root of 9 is 3. But we run into a problem if we ever had like an x squared equals -4, because while I can square root both sides, x equals plus or minus, there are not a pair of numbers that I can multiply together to get a -4. I can multiply 2 times 2 to get +4, but there's no way to get that negative. If it was a -2 times a -2, well, that's +4, so that wouldn't work. And if it's 2 times 2, that's +4. So we always said the square root of a negative number, we would just have to put, can't do it, and we just say that's not real. So we had no solution to that problem. What we're going to see today is by making a simple definition for this new number, the number I, okay, called the imaginary number, we actually can come up with solutions for this equation. X squared equals -4, and we'll see today that the solution for it will be written as this. We still get that plus or minus, but the solution then would be plus or minus 2i. Okay, this I really has a specific definition, which is on the next slide here. Okay, so this imaginary number I, notice it's kind of a curly I. We just don't make it straight up and down like that. We give it just a little bit of a tail to help us recognize it and don't get it confused with the number 1. And the definition of this imaginary number I is it is just simply equal to the square root of -1. And also, if you square it, so if you take the imaginary number I and you square it, you get it is equal to a -1. So we got to remember these two things. And the one we're going to mostly work with today is this I equals square root -1. And let me show you how I applied that. On the previous page, we had, hey, figure out what x is, and I told you it was plus or minus 2i. Well, when you square root both sides, x equals plus or minus, we always get plus or minus. Whenever you square root a negative, what you want to think of this as, you want to think of it as a square root -1 times a 4. -1 times 4 is -4. And the square root of a -1, though, this part of it, that is the I. Square root -1, square root -1 is I. So whenever you see the square root of a negative, one of the things you want to do almost immediately is you want to poke out that I. And then simplify what's left over. So you take the I out, you've square rooted the -1, so there's my I. And then I just have to square root 4. In this case, square root of 4 is 2, and so it's 2 times I. So x equals that plus or minus 2i. All right, so square roots of negatives, take out the negative by making it the number I. So let's look at a few examples here. Here I've got the square root of -25, so I'm going to think of this as a square root of a -1 times a 25. You don't have to write that. In fact, my work looks like this. If I was doing this problem, I'd poke out the I first and write that. Then I just have to square root the 5 and the square root the 25, which is 5, so it's I times 5, or 5I. If I work it this way in red, I'd have that I, then root 25 like that, which is I times 5. This is showing all the steps, which we write as 5 times I. Always put the I behind its coefficient, the number in front of it. So square root 72, or negative 72, I poke out the I first. And now I have to simplify that root 72. And some of us still have a hard time with simplifying radicals. This was a Algebra 1 and geometry skill that was practiced. Let's go ahead and break it down. I'm going to break it down the quick way here. I would try to find a factorization for 72 that includes a perfect square. In this case, I would factor it as 36 times 2. And the reason I'd use 36 is because 36 is a perfect square. It is a 6 times 6. And if it's a perfect square, you can square root it. Square root of 36 is 6, so I get 6i. And what's left inside this 2 is, so it's 6i root 2. Now, if you're not good with that factorization or doing it that way, let me show you the brute force method. So I've poked out the I, now I'm going to start factoring 72. And so maybe you go, well, that's 9 times 8. That's fine. 9 times 8 is 72. And then you keep factoring, and you go, well, 9 is 3 times 3, and 8 is 2 times 2 times 2. This is the prime factorization. Okay, I can't break those numbers down anymore. And when you're dealing with square roots, which this is, all you're looking for is pairs of things. In this case, I've got a pair of 3s. That means I can take a 3 out. Anytime you got a pair, you can take a number out. And I've got a pair of 2s right there, so I can take a 2 out. So I've got my I on the outside. Out comes a 3, because there's a pair of them. Out comes a 2, because there's a pair of them. And then this lonely 2 has to stay inside. Well, 2 times 3 is 6 times I, so 6i root 2. Same thing we got before. If you go through multiplications, though, or multiplication tables, then you can do it quicker by knowing it is 36 times 2. And the square root of 36 is 6. So you get 6i root 2. Same answer, just a little bit faster. And our last example of this type. Oops, we don't do that. There we go. We've already got negative 5 on the outside of the radical. So let's just take stuff out that we can take out. Negative 5. I square root that negative. Okay, square root of a negative is I, the imaginary number. And now we just have to take the square root of 9. So it's negative 5i. Square root of 9 is 3 times 3, or negative 15i. Alrighty. Next type of problem. Complex numbers. Complex numbers is our biggest number set that we will ever deal with here. Okay, and complex numbers are just numbers that can be written as a plus bi form, where a is called the real part, and this b is called the imaginary part. We can't add these two numbers, the a plus bi. So for example, here I have a 5 plus 3i. So 5 is the real portion, and 3 is the imaginary portion. Okay, so to be very nitpicky, you would just say 3 is the imaginary part, okay, instead of 3i. although I don't I think you'd really be arguing over language at that point. So complex numbers are just a number that has to be written because it's got this imaginary portion to it. You've got to just write it as these two different parts. Here's the real part, here's the imaginary part. All numbers, it turns out, are complex. Okay, for example, this second one here, you'll see I've got 7i. Now notice that doesn't look like a plus bi, but it is. It's the same thing as a 0 plus 7i. And so the real part is the 0, and our imaginary part is the 7. Then this last one, hey, 6 here, that doesn't even have an imaginary part, but we can think of it as 6 plus 0 i's. So the real part would be the 6, and the imaginary part is the 0. And we're going to see quite a few of these numbers pop up as we start to solve more and more of the quadratic equations. But let's go ahead and use this idea that numbers have a real part and an imaginary part, which makes them complex numbers, and let's utilize it to solve a problem like this one. If here is a complex number equals this, looks like it's complex as well, what are x and y? Well, if two numbers that are complex, a plus bi and c plus di, if those two numbers in complex mode are going to be equal to each other, then the real parts have to equal each other, and the complex parts have to equal each other. That way they would be the same number. So if we look at this equation up here, the 2x is the real part on the left side, so it doesn't have an I next to it. The 10 is the real part on the right side, there's no I next to it. So the real part has to equal the real part. So 2x must equal 10. So we can write that little equation. 2x must equal 10, divide by 2 to get the x alone, so x must be a 5. So now we know what x is. And in fact, if x was 5, 2 times 5 is 10, and the real parts would match. Let's do the imaginary part here. This negative 7 has to equal this y. We don't have to worry about the I part. We just worry about the numbers in front of the I part. So, okay, so negative 7 must be equal to y. Well, now I know what y is. Y is, I should write it left to right, negative 7. And so if y is negative 7, you get 10, and this would be minus 7y, or 7i. And if x is 5, you'd get 10 minus 7i, and the two sides would indeed equal each other. So all we had to do is figure out what x was and y was. Put the real parts equal to each other. So a must equal b, or c rather, and then the b must equal the d. The real parts have to equal each other, and the imaginary parts have to equal each other. Oh, an addition problem. Here's two complex numbers. You got a real part, an imaginary part, got a real part and an imaginary part. And to add them together, all you have to do is add real to real. So you add the 8 to the 5. That's the real part. That's 13. And then you add the imaginary part, negative I plus 4i. That's 3i. Negative 1i, think of it as a 1 in front of the I. Negative 1 plus 4 is 3. And that's it. You cannot add the real and the imaginary part together, so you are done. Add real to real and imaginary to imaginary. This is a subtraction problem. Same idea. Real to real, imaginary to imaginary. However, when we subtract this 3 minus 8i, it really means to distribute. So it becomes 7 minus 6i. We have to distribute that negative to make sure we subtract the entire thing. It's a negative 3 plus 8i, negative times negative. And then we just simply add the real parts together. and we do whatever the imaginary part says. Negative 6 plus 8, so it's going to be 2. So it's plus 2i's, and we are done. Just add the real parts together, the imaginary parts together, and you're finished. Alright, you got 10 problems. They don't take too long, but spend some time on them so you can come back with questions.